Welcome to qnawire.
Hi. So we are given the capacitance of parallel plate capacitor when there is air between the plates as 8 picofarads. So for parallel plate capacitor with air between the plates, the capacitance C naught equals 8 picofarad, and the separation between the plates is given to be 1.5 mm. So the separation between the plates is 1.5 mm. Now, in the first part of the problem, we have been asked what is the maximum magnitude of the charge that can be placed on each of the parallel plates if the electric field in the region between the plates is not to exceed 3 times 10 raised to 4 volt per meter. So the electric field between the region should be less than or equal to 3 times 10 raised to 4 volt per meter. So this is the maximum possible value of the electric field, and we need to find what is the maximum possible value of the charge on each of the parallel plates. So we know that for parallel plate capacitor, the electric field and voltage are related by this combination. So for part A, the electric field and voltage is related like this. So electric field E equals V by T, and from this we find the potential difference between the parallel plates is given by V equals the electric field times the distance between the parallel plates. Now in our case, the electric field, the maximum possible electric field is given to us, which is 3 times 10 raised to 4 volt per meter. This is the maximum possible electric field, and the distance between the parallel plates is given to be 1.5 millimeter. So in terms of meter, it's going to be 1.5 times 10 raised to negative 3. And if you calculate this value, the value of the voltage comes out to be 45 volt. So this is the potential difference between the parallel plate when there is air in between plate. Irrespective of the air, this will be the potential between the parallel plates, since the electric field is given to us, which is 3 times 10 raised to 4. So having found the potential, now we can very easily find the charge on each plate. So the maximum possible charge is given by Q equals C naught V, where C naught is the capacitance of this parallel plate capacitor, which is already given to us to be 8 picofarad. So if I substitute the values, so the capacitance is 8 picofarad, so 8 times 10 raised to negative 12, and the potential which we have already found to be 45 volt. And if I calculate this value, the maximum possible charge on each plate for this parallel plate capacitor when air is present in between is simply given by, it is equal to 360 picocoulomb. So this is the value of the maximum possible charge on each plate. So this is the answer for the first part of the problem. Now for the second part, we need to find the maximum possible charge on each plate if there is some dielectric material other than air present in between plates. So the dielectric material with a dielectric constant K equals to 0.7 is present all over in between the plate. So now in between this parallel plate, we have a dielectric material with a dielectric constant K given by 2.7. And in this case, we need to find the maximum possible charge on each plate, and the electric field is 3 × 10⁴ volt per meter. So we are going to use the same logic here, but in this case, the capacitance of this parallel plate capacitor is going to be different. So since when you have a dielectric, the capacitance becomes Ck equals epsilon naught A over D. So there is a multiplicative term here, which is K, which is a dielectric constant. So since this term, epsilon naught A over D, is nothing but the term for C naught, which is the capacitance when only air is present. So I can write Ck as K times C air, where C air is the capacitance of the parallel plate when air is present, which we already know. So K, which is the dielectric constant of the material, is 2.7 times the dielectric constant, the capacitance of the capacitor when only air is present, which is given to be 8 picofarad. And if you calculate this, the new capacitance comes out to be 21.6 picofarad. So this is the new capacitance with the dielectric material with dielectric constant 2.7. So with this new capacitance, you can very easily find charge, the maximum possible charge on each plate to be CKV. And if I substitute the values, so CK is 21.6 picocoulomb, so 10 raised to negative 12 times the voltage, which is again 45 volt. And this value comes out to be around 972 picocoulomb. So this is the maximum possible voltage on the parallel plate capacitor when a material with dielectric constant 2.7 is placed in between the parallel plates, and the maximum possible electric field applied is around 3.3 times 10 raised to 4. So this is the maximum possible charge on each plate. With this, we finish this problem. Thank you very much.